Hi, good morning everybody. So my name is Daniel. I'm from SEGI University College in Kota Damansara. So today we'll do an experiment which is about the heat exchanger. So as you can see, this is the heat exchanger training apparatus. We have a variety of heat exchanger over here. We have the shell and tube heat exchanger, spiral heat exchanger, as well as the concentrate heat exchanger. But today we mainly talk about the shell and tube heat exchanger. So now I'll give a short introduction about the shell and tube heat exchanger. So shell and tube heat exchanger basically will be divided into two terms, which is the co-current flow as well as the counter-current flow. So co-current flows is stating that the hot fluids and the cold fluids will be flowing in the same directions, and hence the fluids will be entered and exit at the same end. So now for the counter-current flow, the hot fluids and the cold fluids will be flowing in the opposite directions. They will be entered and exit at the opposite end. Before we start our experiment, we need to do some setup. This is the schematic diagram for heat exchanger training apparatus. Before we start the experiment, we need to arrange the valve for the flow selection. So first, for the counter current, we need to open V1, V12, V16, V17 and V28. So for the closing valve for counter current, we need to close V15, V18, V27, V29 and also V30. So now for the valve that leave alone, we'll leave V2, V3, V4 until V11 and also V13, V14, V19 until V26. So those are the valves that leave alone. The settings will be like this as shown in this picture. There's a variety of heat exchangers, but for this experiment we are doing this particular shell and tube heat exchanger. So for the valves arrangement for shell and tube heat exchanger, we'll open the V4, V5, V19 and also V20. So for the closing part of the valve, we'll close V6 until V11 as well as V21 until V26. In this picture, the valves are open. It is because the valves are parallel to the stream. However, in this picture, the valves are closed. To start this experiment, I need two students to help me. So one student will be standing over here to control the water tap, and then one student will be standing over here to supervise the water level. So the left tube is the hot water stream and the right tube is the cold water stream. However, in this experiment, we fix the hot water stream, which is the left side, into 10 liters per minute, while for the right side, the cold water stream, we set the water flow rate to be 2 liters per minute and until 10 liters per minute with an interval of 2 liters per minute increment. We need to wait the temperature controller to reach until 50 degrees Celsius. When the temperature controller reach 50 degrees Celsius, so we can record down the TT1 until TT4. But because the temperatures are fluctuating, so we need to wait all the temperatures in steady state, only we record down the values. By the way, the main objective of our experiment is to calculate the LMTD, the heat transfer coefficient, and also the heat loss. The LMTD is the log mean temperature difference, which I will further elaborate later on. And the heat losses we'll calculate by this experiment, which is calculated on the Q hot and also the Q cold. And lastly, the U, which is the overall heat coefficient, will be calculated later on based on the equations we're using. After we done all the calculations and the value are recorded down. So this is the calculation part, and all the temperature will be recorded down from TT1 until TT4. And for the mass flow rate, we change it into the SI unit of kilogram per second. Now we need to calculate the heat transfer for the hot stream. So the formula is MC times with the temperature difference. So the CP is a heat capacity at the constant pressure. So after all the value calculated, we get the result, and same calculations for the heat transfer inside the cold stream. After calculating all this, we need to find the Q loss, which is the heat transfer loss. So for this one, we use the Q hot minus Q cold, and we get the result.